nice diagram, the complete, all the system views that you have in SQL Server. Now this is something that you can, if you have that much space, right? At your office or at your workplace, you can always take it. It's something really nice. Price of this is 1,90,000 or something, around that much. Because I got 2 of them and I had traveled to US to get them. So I got them from SQL product team from Redmond. My total trip cost was 4 lakhs around. So per piece is by that logic. And it's very coveted because you don't get such things in India. Right? You don't get these branded goodies, right? I mean, SQL. And there's another one. So there's another one which says SQL Server, it's a poster. Now there's nothing special about this poster. I got this at SQL Bits conference, which happens in UK, and I was speaking there. So if you use this poster and you put your glass of water on top of this, that water performs very well, is highly available, very robust and reliable. It means all the features of SQL Server. Okay, so well, I have not used this. I have not stuck this on my table, but I use this on my table. So I have these two, and I'm not going to tell you who's going to get this. You know what happened in one of my previous conferences, previous sessions? I actually I told that people, someone who asks me the most questions, both in terms of quality and quantity, will actually get this poster. And you know what? There was a guy. Every bullet point on the slide, he had a question. I had to literally tell him not to ask me questions. I gave him a poster anyways after the session. So I'm not going to tell you, and please don't think that if you ask me more questions, you'll get this. I will see who asks me, how you interact with me, etc., and then I will take. I will do that judgment, and my judgment is going to be final. No dispute on that. Okay, so welcome everyone to SQL 2014 eXtreme Transactional Processing session with long title. It could be simply SQL Server 2012 in-memory OLTP. Now, Hekaton is actually, it was mentioned as Hekaton if you see your slide. So Hekaton is actually the old project name, right? It has been under development for about 4 years at SQL Server product team, and the new branding is in-memory OLTP. So about me, well, what do you want to know about me? I'll keep it very short that way. Is there anything you want to know about me? What do you generally want to know about a speaker? Nothing? So I started pretty much in time, so I have a quick slide, a little bit of fun stuff here, okay, which talks about me. So let me put that across. I was born on August 30, 1980. Okay, this is a slide about me which talks both technically, which means professionally, as well as personally. So I was born on August 30, 1980. That time, Indian Bollywood star Amitabh Bachchan was at his peak. So my parents named me Amit. No jokes, that's the fact. Okay, and I'm a big fan of it. Moving forward, and that time I had no knowledge of SQL Server. Class 6 was the first time when I actually saw a computer inside our school. That was a room which was very chilled, used to be very chilled, because that was the only room that had air conditioning. And those were microcomputers. You see that icon on your screen is exactly what I saw. And we used to be very excited and delighted only if we got a look of that computer. We didn't get to touch that computer. We didn't get to enter into the room. We could only see it, by peeping through. And so we were very fascinated, and my brother, who is 2 years elder to me, we always wanted a computer and moved quickly. 1992, our father got us our first computer. It was Wipro 386DX2. Then you can come this side. It was Wipro 386DX2. It cost us in 1992, which included a dot matrix printer of 20K. So my father actually bought it for my elder brother because he was very productive in terms of wanted to learn, he wanted to program, etc., etc. So what happened since 1992 to 1996, all that I did was play games. So I played Wolfenstein 3D, I played Prince of Persia, I played Syndicate, everything. And my brother did all sorts of programming and everything. And this led to my father being very disappointed because all that I did with the 1,20,000 computer was play games. Well, I got a little serious and I started learning all the languages that you can think of. Okay, Fortran, Pascal, GW Basic, C, C++. And then I got introduced to VB and Visual Basic 6. And in those years, I was also very fascinated with a lot of graphics work. So I put my hands dirty on SQL Server and, no, not SQL Server, the lightweight 3D Studio Max, and we used to do a lot of graphics work also. A little bit of seriousness came in year 99-2000 when I got my first Microsoft certification. You know, you give one paper and you become an NCP. So I actually got certified on Visual Basic 6. I also started working part-time. And then I did a lot of graphics work. You will be surprised that I did not do much work on Visual Basic 6, but did a lot of web development, etc. for companies. And then I joined eDominer in year 2002 as a developer. And that was the time when Microsoft Certified Trainer certification also came to India, and I was certified. So I was the first Microsoft Certified Trainer in India. And after that, because I joined as a developer, I worked heavily on Visual Basic and SQL Server, heavily. Up to the number of projects I did. I also got certified as NCSB.NET, early achiever in 2003. 2004, I started Peopleware India as a unit under eDominer, where we did a lot of consulting and training. 2004, I did my first professional training and consulting assignment with Accenture. Moving forward, SQL Server 2005, I got associated with Microsoft. I participated in SQL Server 2005 launch, PAN India. At that time, I also got certified as MCDS, Microsoft Certified Technology Specialist. Moving forward, that was a breakthrough. 2007, I got selected as SQL Server MVP. That's an award that you might know of, that Microsoft gives to an individual if you demonstrate credible expertise around the product. I also was fortunate enough to be invited to proctor certain hands-on lab in TechEd 2007, which happened in Orlando in North America. TechEd is Microsoft's global conference where people, IT professionals all over the world participate, and you have some of the best speakers out there. And I have a very bad habit of daydreaming, so when I went to TechEd 2007 in US, that was my first US trip, I looked at the speakers and I thought that, you know, we speak it in India, and you know, it's always good to speak at global platforms, and that really fascinated me. And lucky enough, my daydreams sometimes come true, and I got an opportunity to speak at TechEd Euro 2008 in US as well as in Europe on SQL Server, of course. Moving forward, I spoke at TechEd India in 2009. I spoke at NCP Summit. I delivered sessions at MVP Summit. I was the first MVP to also participate in SQL Server 2008 certification process, the NCTS and CITD certifications that you see. I also got married at that time in 2009. SQL Server Geeks.com. Has anyone heard of SQL Server Geeks.com? Okay, some of you. So I started that in 2010, and in 2011 I had my first kid. I also spoke at TechEd India in that year. I also delivered sessions at Tech Valley Redmond. TechEd 2012, I delivered a session there. These are certain milestones, so it was very fortunate to be speaking at TechEd again. I also spoke at Gates. That was my second experience at Gates. TechEd 2013, I delivered a session at TechEd Europe, followed by last year, not last year, in fact this year, it was at the edge of last year. I also got certified as Microsoft Certified Master of SQL Server in India. And then yes, this year, I'm speaking at Gates, and I'm also speaking at TechEd North America. Some of the achievements that I have with this career is being the first MCT, also member of MCT Advisory Council, joined as a developer in my company, and now I hold the director position. More professionally, I hold the CEO position, and we have built 120 customers pan-India, delivering more than 500 plus assignments. Also, I happen to be the longest SQL Server MVP in terms of tenure, with more than 12 years of experience on SQL Server. I'm also part of the Data Platform Advisory Council. I was the first speaker at TechEd 2008. So that's a separate story. If you want to know about it, you can always talk to me offline, and I will tell you what that story was. And after that first global session, which was really worst, I was the worst speaker. My next session, I came in top 5 speakers. So that's an interesting story. What changed? Well, moving forward, I became the first and the only SQL MVP who participated in SQL Server certification process. Moving forward, SQL Server Geeks.com has its own success story. We are the only SQL Server community in India India, which does SQL Server Day, our events. We do it pan-India. We clock close to 2 million page views on per month basis. I also got the top 3 speakers slot, my game in Tech in North America, and surprisingly, I think I'm not so good, but I got the top speaker slot at Tech in Europe last year. And with Microsoft Certified Master, I happen to be the only MCM in India outside Microsoft. And with this year speaking at TechEd, this is going to be my 6th TechEd appearances, the only one from India. So that's about me. A little long slide, but I've given you complete history starting from 1980 till date. Okay, thank you. So let's talk about in-memory OLTP and why are we here. So the agenda and your takeaways are going to be as follows. We'll talk about the business and hardware trends, what really is in-memory OLTP, Hekaton, what are the different architectural pillars, and then I will show you a demonstration. And I really want to keep more time for demo than discussions. So hardware trends. Now if you go back and look into the history of databases, if you go back and look at the history of databases, we had the DB2 thing in 1970s. We had Oracle in early 1980s. We had Sybase again around 84, 85 around, and then Microsoft took a version of Sybase, and then the history. We had the first version of SQL Server, so on and so forth. During those years of 70s, 80s, etc. Databases used to run on hardware, and hardware was so different from hardware that we have today, right? In terms of capacity, storage capacity, in terms of computing power. And today, the hardware that we have, there is leap and bound of difference, right? It's a leapfrog. If you think about today's computing capacity, and if you think about today's terabytes and petabytes of storage capacity. So obviously, with changing times in hardware, even the software has to change. And that is where in-memory OLTP engine from Microsoft SQL Server team is one of the biggest improvements that have happened, keeping the current hardware trends in mind. Right? And I'm going to elaborate that on a little more. But one of the key points that I want to show you here is, if you go back, today you have chips with like 3.4 gigahertz, etc. Right? You have quad-core boxes, quad-core CPUs. It's not uncommon today to actually see boxes with like 128 cores, 256 cores. It's very common. And 24 and 64 is obviously very, very common. I mean, so when you actually want to buy an enterprise server hardware, that's probably the starting point. But go back to the history, and if you go back to the Intel Pentium history, where did we start from? 133 megahertz, 166 megahertz, 266 megahertz, do you remember? Right? And what was the development cycle? You moved from 133 to 266, 266 to 333. You are always doubling the computing capacity, right? Okay? So, a typical law here was double the processing capacity and you can have more instructions, double the instructions you can run on that CPU. But today, today the trend is CPU processing speed has plateaued, right? It has come to a halt. It has come to a limit, which is beyond 3.4 gigahertz kind of thing that we have today. You cannot go beyond that. So you had a very nice graph scaling up, but there is a time now where it has plateaued. You can't actually get double processing capacity, or you can't increase the clock speed. The clock speed has plateaued. So what do you do now? How do you increase your transactional capacity? How do you ensure that you have low latency and you have high throughput? Isn't it? You will have more complicated softwares coming up, more complicated code that will run. You will have more users connected to your applications. If the clock speed does not increase, how do you ensure more transactional throughput? So there are a couple of things here. One is, what are we really talking about when we talk about computing capacity or processing power? So the point here is the number of of instructions that you are actually running on a CPU, right? That's what clock speed would, in a very simplified manner, clock speed defines the number of instructions that you run. So if the clock speed has plateaued, if it has come to a halt, you as a developer can do something, program in such a way, code in such a way so that you decrease the number of instructions. Point number one. Point number two, you decrease the number of instructions and you will get support from hardware vendors in terms of today multi-core processors, right? Quad-core, hexa-core, octa-core, right? Multi-core processors. So you're actually scaling up, but you have more sockets on the motherboard and you have more multi-core chips on motherboard. That's how you can actually increase computing capacity. But in a linear fashion, having a single physical processor just scaling up in terms of clock speed is plateaued. Are you getting my point? So in-memory OLTP is actually designed keeping these hardware trends and CPU trends in mind. Are you all with me on this page? I'm going to come back to this point again. So what is the takeaway from this slide? The takeaway is you have to increase, or you rather have to decrease the number of instructions that you send to CPU so that you get better throughput, right? And of course you're scaling up with more cores on a single motherboard. So what is in-memory OLTP? It's a high-performance, memory-optimized OLTP engine integrated into SQL Server and architected for modern hardware trends. Let's break this apart. And if you see, in-memory high-performance engine, obviously it's a high-performance engine, memory-optimized. How many of you work as database administrators with SQL Server? You're in a DBA profile. All of you are into developer profile? Yeah? Do you know how buffer pool of SQL Server works? Data is stored on pages, right? Data is stored in pages. Page size is 8 KB, right? And what happens when you want to access data which is actually stored on that page is actually brought into memory. So think about it. We are talking about in-memory OLTP. Well, even in traditional SQL Server engine that exists today, prior to 2014, you still have data or pages in memory. Then how is it different? The difference is that's in memory, but is still not memory optimized. Here, it's going to be in memory and it's going to be further memory optimized. So these are the points that we have to take. High performance engine, it's going to be memory optimized, integrated into SQL Server. And what do we mean by integrated into SQL Server? It's not a different product. It's of course a different engine, but integrated into the same SQL Server that you and I work with on an everyday basis. So you don't have a new engine to learn, you don't have a new tool to explore or something like that. Okay. And of course, modern hardware trends. We have started our discussion with modern hardware trends. So let's move and look about the in-memory OLTP pillar. And now this is one of the most important slides from conceptual perspective. And let's go through this quickly so that I can come to my demos. All of you know we can create tables in databases, right? And then you create indexes on those tables, right? What kind of indexes? You have clustered indexes and non-clustered indexes. So suppose you have a table called employees. You have a clustered index on employee ID. There are certain other columns like email address, first name, last name, and there is another address called column called postal address. Okay, you have created a non-clustered index on email address, right? And now you want to search. So let's start from this table employees, where email address is equal to something. What's going to happen? The SQL Server engine is going to first fetch the non-clustered index. Non-clustered index is a B-tree structure. They go to the root page. From root page it will jump to the intermediate page to leaf page. And you might have multiple intermediate levels, right? So assume that this non-clustered index has 5 levels, right? Root page up to the leaf level, which means traversing has happened from root to intermediate to leaf. Are you getting it? Now you might want certain additional columns which are not part of that non-clustered index. What will you do? You will jump from non-clustered index to clustered index. And when you go to clustered index, again you are going to traverse 5 levels. All of you with me on this? Now think about this. This data is already in memory. This data is already in memory, true or false? But you still have to traverse at least 9 or 10 levels. Or let me put it this way, you still have to read 9 or 10 pages to fetch that one record. And every time you read a particular page which is in memory, SQL Server has to latch that page. That's an advanced concept in SQL Server called latching. It's not locking, but it's latching. In memory, short-term, lightweight synchronization object that SQL Server needs to maintain integrity of your data. So every page has to be latched and it has to be there. Now this is extremely fast, but still the engine has to do so many things. Are you getting it? Now, yes.
What is the latching difference from locking?
Offhand discussion. It's a little offhand discussion. I'll be happy to do that with you post this conference. But to give you a short summary, locking is user controlled. When you specify in which isolation level you are running, read committed, uncommitted, and you take different types of lock, exclusive lock, update lock, or shared lock. Latching, on the other hand, is automatically done by SQL Server at the 8 KB page level. Very quick example. You want to insert record into that page, right? So there is a page header. Page header has a lot of metadata. That process that SQL Server is going to insert a record, after the record is inserted, the amount of free space on that page is going to change, true or false. It has to update it on page header. So it has to hold a latch on that page to maintain the data integrity of that page.
Deadlock is still possible in latching.
Deadlock is a completely different concept. Deadlock is a completely different concept. It has nothing to do with latching. It comes with our user locking concept. Okay. Now compare this traversing through 5 levels and jumping from one long cluster index to the clustered index, and then in the process of latching, compare this with a concept called, suppose all these records were in a bucket and they were hashed, right? Typical computer science hash tables, and then you have a hash index. So all the engine does is just gets the hash index value, goes to the right bucket, picks up the record. Now if you compare this with the traditional structure, this is going to be much more fast. It's going to be extremely fast because you're going to get rid of the latching process, and the number of hops you have to do or the number of page reads that you will have to do will all go down dramatically. And you're going to see an increased performance in this hashing concept. So that is your first pillar. Memory optimized. Now, if I take this table, which has all these page structures, etc., and I really convert it into an in-memory OLTP table, friends, everything will change. There is not going to be any page concept. Data is going to be stored differently. Okay? If there are no pages, there will be no latching. Now what has happened? Even though when we were going into traditional SQL Server concept, the pages were still in memory, they were not memory optimized. Now here, this data has to be in memory. So let me make it a point. In memory OLTP data needs to remain in memory always. It needs to remain in memory always. But now in this case, it's memory optimized. So we are actually moving from a buffer pool traditional SQL Server concept to this new in-memory concept. And I just talked about this hash indexes. That's one of the important pillars. The second important pillar is, let's talk about TCP. Yes, question. Right. How do you search? Because every record is going to be hashed. So you will have a hash index value. You are going to create buckets. Every bucket will have a certain number of records. For example, you have 10 million records. You create 10 buckets. Each bucket will have 1 million records. And this hash index is going to be created for SQL Server every time when SQL Server starts. And this hash index is going to remain in memory. Are you getting it? That's how it's going to happen internally.
Excuse me?
Yes.
So it's always the hash tables which is used as a data structure and nothing like trees and all.
Yes, absolutely. So when you are moving to in-memory OLTP, you have to specify that in your current database you have so many tables, right? You're not going to convert all tables into in-memory OLTP. The tables that you want to convert to in-memory, they will always be converted to hash indexing concept, and they will always remain in memory. I will come to the demo in a short while. The second pillar is your T-SQL. Now let's talk about your T-SQL code. T-SQL is a huge language, right? But it is an interpreted language. What do you mean by interpreted language? When you say select star from this table and do a sum, do a sort, etc., etc., I am sure you might have seen execution plans, right? And you see how execution plans define step by step what's happening, right? So in T-SQL, what you see in graphical execution plans are actually what is happening behind the scenes, right? Your code is being parsed, right, into a query tree, and it is being interpreted, which is fetch the data. So every operator opens, closes, then your sort operator, it opens, performs the job, closes, right? Step by step interpretation is done, which means a lot of instructions are being passed to the CPU. Now let's go back to our first slide. What did we talk about in first slide? You want more throughput, right? You want transactional capacity to increase. You have to reduce the number of instructions. And one of the fantastic things that SQL Server product team has done is they have taken this T-SQL code, right, which is T-SQL language, and has converted it into machine code, C code. Are you getting it? They have converted it into C code, and they've taken a Visual C compiler and compiled it into machine code, producing a DLL. Isn't it awesome? That's what is going to happen in SQL Server when we talk about in-memory OLTP. Right? And I will show you a demo of that. So what really it means now? Your T-SQL, you're going to write the way you write T-SQL, right? But of course certain constructs and structures will change, and when you execute that code, behind the scenes what's going to happen? It's going to convert it into a C code, and it's going to be compiled into a DLL. Okay, which means what? You are with that, you're actually going to reduce the number of instructions. Compare it with that T-SQL thing that we talked about, right? Moving from, operator by operator, and every operator open, perform, close, you're reducing the number of instructions. One of the tests that SQL Server product team did, and they demonstrated this in one of the sessions, is in a typical T-SQL, a standard T-SQL stored procedure was taking about 1 million instructions, right? And then they converted that to a C code, a DLL. It completed it in about 40,000 instructions. 1 million to 40,000 instructions. We're not talking about 2 times or 3 times. We're talking about performance gain of 30x and 40x. And you're going to see that. That's your third thing. Okay. Second thing. The third one is concurrency. Now because page structures are not there, latches are not there, you get a highly concurrent environment. Right? Concurrency is badly affected when you have page structures and you have all sorts of latching and locking happening. Concurrency is still there. In-memory OLTP does not mean that concurrency is not there. Concurrency is still there and your data integrity is still maintained. But that is again a very different concept as to how concurrency is maintained in memory OLTP, probably another session. Last but not the least, as I said, it is integrated with SQL Server. Okay, it's the same SQL Server product. You don't have any new tool or interface to learn, but of course you have to understand this new concept. So I will come to this slide a little later. I first want to show you a demo. Okay, I want to first complete my demo and then I'll come to this slide.
Just a quick question on
Yes.
the concurrency issue, which I think you are telling us
Well, I have 12:45, right? How much time is left?
Nearly half an hour.
And half an hour. Yes. So yeah, please, your question.
when there is a rush for the same resources, right, by 2 or 3 instructions, and how do they manage?
Rush for same resources.
Objects.
I hope you're not doing it because of the.
No, actually, we are having something.
Okay. Concurrency, the way it happens in SQL Server in traditional product is going to happen exactly in the same way that we have here, right? But to answer your question, you have to first understand the locking and latching architecture that exists today in SQL Server, right? Then only I can compare it with what we have in 2014. How does it work in traditional base? Shared locks, right? Exclusive locks, I mean typically if you go about shared locks, exclusive locks are two most common locks. So when you want to read, you have shared lock, right? So record can be shared. Shared locks are compatible with another transaction's shared lock. Exclusive locks are not compatible, which means a particular transaction is holding an exclusive lock on the record, the other transaction has to wait. That's how concurrency is done. Concurrency here also will be done exactly in this in a similar fashion, but the concept of latching is not there. Okay, concept of latching is not there. So let me first start with the first demo. I changed this SQL Server. I was just playing something. Yeah. We keep doing all sorts of things with SQL Server. So I have SQL Server 2014 installed on this, and while I do this demo, I'll tell you a lot of things about SQL Server 2014. Just like caveat points, right? You can't have SQL Server 2014 and another version of SQL Server side by side, right? You can't have SQL Server 2012 and SQL Server 2014 on the same box because architecture of SQL Server 2014 has changed. So let me first open up my setups. Now, what I am doing in this setup is, friends, I have created two sets of tables. As I say, I have created two sets of tables. One set of table, so let me quickly go and run this. One set of table is So what I've done is, let me go and show you the code here with one of the tables. Look at this table now. Let's look at this table. This is a table where you can see it says create table, something, something. You say sales order in memory, right? And if you see, and I will explain you this as time permits from it, you see hash with bucket count of 4 million. Do you see that? Okay? And where do I... So this table that we create, so this is one of the new things that you will see, right? What I have done is, I have also created another table. So you see a couple of tables with this in-memory thing, right? And then along with that, you will see a constraint which says primary key non-clustered hash. So I create hash tables and I create hash indexes. There are a number of other tables that we have. Let me scroll down. You see sales order header, it says on disk. And these are your traditional tables that you will very well understand. So what we have done is, I've taken 5 or 6 tables from AdventureWorks database, right? The disk tables. So I'm going to use this term, on disk tables and in-memory tables. On disk means traditional tables, and in-memory means our memory optimized tables. So I've taken the same tables which are disk based and I've converted them to in-memory. And now I'm going to show you performance when I work with disk table versus in-memory, right? So I will give you the script, so you can always go through it in detail. So I have a bunch of such tables, and along with that, what I have is, let me see if this code has run. This has run successfully. I will open my next piece of code, is create stored procedures. And now what I have done is, here if you see there are certain stored procedures like demo, insert sales orders, insert sales order details, etc. What is this stored procedure going to do? I am going to insert data to this stored procedure, right? And I am going to pass a parameter. 0 means use disk-based tables, in-memory means, 1 means use in-memory tables. That's the only difference. I'll call the same stored procedure, insert data, bombard these tables with data, concurrent access I will do, and 0 means use disk-based tables, and 1 means use in-memory tables. So let's come to Fire. Now, this is our first piece of demo, and watch carefully on the performance. Use AdventureWorks 2012, and what we are doing, we are calling this stored procedure. I say use in memory, and I say 0. 0 means use this page tables. I want to insert about, what is that, 10,000 records. I want to insert it, and after that, do I want to update that? No, I don't want to update that. This is an additional parameter. Okay, so I'll just do an insert performance. Now, when we execute this, how much time does this take? Is what you will have to see. How much time? Now, there is a very classic problem in SQL Server which is called as the last page insert. Last page insert. You have 1,000 users trying to insert data. The data has to go to the last page, which is whichever that page is, right? And all 1,000 users are going to access that page. All of them are not going to insert data at the same time, isn't it? That's where logging and latching comes into picture. Users have to wait, and it's going to happen one after the other. So can you imagine that throughput is going to be affected very badly? This is a very classic example of a last page insert. The only difference here is I am showing this to you with just one user connecting and performing his job. How much time it has taken? 34 seconds. So that's what this has taken. Okay. Now let's insert data into in-memory tables. Let's insert data into in-memory tables. I have used parameter as 1. How much time will this take? Any guesses? 1 second or 2 seconds. Okay. Very optimistic. But it's always good to be optimistic. Remember, so this has taken 12 seconds. Yes, question. Okay, you guessed 12, that's what you meant to say. Okay. So it has taken 12 seconds, 34 versus 12 seconds, right? That's a good 3-time improvement. But it's nothing like blazing fast performance, or what we call as 30 or 40x, right? It's nothing close to that kind of what I try to explain to you. So, some of us, what we do is we just show this much of demo and we walk away. That's in-memory OLTP. That's not in-memory OLTP really. The fact behind in-memory OLTP is this was only one user doing the job, right? The real performance of in-memory OLTP you can see when multiple users are trying to insert or update data. That's where throughput comes into play. Okay? And now I'm going to demo this to you again with multiple users. So I will go to database, file, let me copy the, that's your database name. I'm going to work on Adventure Works 2012 and test connection. Succeeded. I will take this, and let me also show you are our records same. If we do a count, see these are the tables where we inserted data, right? On this in memory, on this in memory. If I do a count, right? Same amount of data. Okay. Now, what I will do is I will clear this data, okay, and just reset, which is going to actually truncate the tables. And now I will also monitor this. We talked about latching, right? So I want to see how many latches are there. Currently, if you see, my latch, there's a count of 51,000 latches, right? Let me reset my latch stats. When I reset this, and you will see it's all 0 now, right? Let's get real now, right? Let's get real and monitor XYZ things. And I want this is the core. This is the core of today's demo. At the same time, I am going to launch perform counter. And I'm going to see latch waits per second, and I'm going to see batch requests per second. Okay, we'll observe these things. Okay, we'll observe. So, all good. We have set up the stage. Let's take this code and first do. And now this is going to take a lot of time. So I'm not going to insert 10,000 rows. I'm just going to insert 1000 rows. Okay, but we will have 100 users doing this job. Okay, and while 100 users bombard this table and try to insert 1000 records per user, you're going to see a lot of latch contention because this is traditional SQL Server, right? I'm using parameter 0. That's one of the things you're going to watch. Latches that are occurring in the system. Second thing you will watch is what is a batch request per second. Batch request per second actually determines the throughput that you're getting from SQL Server. We are going to see that also. Shall we begin? It's going to take about 2 to 3 minutes, but I want to do this. Okay, so let's go and click on Go, and let's go to perform and see. Now, if you see, my batch request is 1, 2. Do you see that? Yeah, look at a high latch rates there, 11,000, 7,000, 10,000, 9,000. This is literally 2. Okay, there you got 2, right? It's literally not changing, right? You're getting 1, 2. Why? Because there's so many users trying to insert data on that last page. Classic last page contention in and traditional SQL Server disk-based tables with latching and locking. And so one thing, batch request per second throughput is very low, very low. It's like 0 or 1 or 2, and latch width is very high. Okay, that is what is going on. Now while this goes on, I want to go back to my slide and show you the disk-based table that I have created. This is how I am creating disk-based tables. No, store procedure is a normal store procedure. It's not the C code store procedure. Okay, so good point out there. So you become a candidate. So here is the table that I created, right? Those sales order header and sales order details. And important things for you to note here is primary key not clustered that you're creating. Now it's a compulsion. You have to have a index. Otherwise, hash indexing won't be done. You see bucket count of say about 1 million, right? And traditional best practice is so you have created 2 indexes here. Okay, 2 indexes, one on name. Yeah, this is what I wanted to show you. One on name, and the other index is on customer sales. Okay, so 2 items on which you create indexes, so that you can actually search based on any of those indexes. So when you put these indexes in your where clause, correct, predicate, what is SQL Server in-memory engine will do? It will actually go and fetch the hash index from these buckets. Now what do you mean by bucket count? Which means in a single bucket you will have those many rows, right? In a single bucket you will have those many rows. And then you also have to say with memory optimized equals to on, which is like a clause telling SQL Server that this is going to be a memory optimized table. Now these are all part of mandatory syntax. Last but not the least, you say durability equals to schema and data. Now this is an optional thing that you want. When you have stored data in a table, you definitely want the data to be persistent in between SQL Server restarts, true or false. You want the data to be persistent, so you can leave this as schema and data. But think about scenarios like ETL, where you create temporary stage tables, right? And you create temporary tables in 10 DB, etc., right? Global and local temporary tables. So what you can do now with in-memory OLTP is you can just say durability equals to schema. So when you do that, this table becomes a kind of a temporary table. You can store the data, but when you restart SQL Server, data is going to go away. That's good. That's not for our transaction tables, right, where you want to persist the data, or temporary staging tables. That's just an option given to you if you want to use it. So it still becomes independent. Yes.
Suppose my table is having multiple partitions, and I want to have only the partition. Can I implement this?
Very good question. If your table is partitioned, can you implement in-memory OLTP on a single partition? With this current first release, that's not possible. Okay, so the entire table has to be in-memory OLTP. Parts of that table, partitions, is not possible. Okay. Now let's see if that is done, and what output do we have? Oh, it's still going on. I should have inserted about maybe just 100 records.
And one more question earlier we were having something about the ABCD in table command. So how is it different?
DBCC? Okay, DBCC print table command anyways is not functional anymore. Since the release of SQL Server 2005, if you write DBCC print table and you put the table name, it's going to give you command completed successfully, right? Okay, but what's going to happen? Nothing is going to happen because all the code behind DBCC print table has been commented out. Okay, so it's like deprecated. Let me put it this way: it's deprecated, but the command will not throw any error. I mean, simply because if someone has used DBCC print table in their applications, etc., they should not break, right? Applications should not break. So that's how it is. Because buffer tool is very well coded. It's a wonderful engine. Buffer tool automatically keeps a track of number of pages that should be there in the memory, for how long they should be there, and when there is memory pressure, which page is the best candidate to be kicked out from the memory. All that is very well designed by the, very well implemented by the buffer tool. So there's no need of DBCC print table. And let me also tell you, this is not similar to DBCC print table. There's a lot of difference. DBCC print table simply said, take this table, put it in memory, right? Here we are doing that, but a lot of other things that we are doing, with hashing, bucketing, with creating multiple indexes, right? The concept is very, very different. And with stored procedures, is equal to C code, right? So it's completely like comparing apples and oranges. But very good, because people who have been working with SQL Server will always have this question: is it similar to DBCC print table? The concept might sound similar, but architecture-wise, technology-wise, it's completely different. Okay, so we are done. It took us about 4 minutes, 31 seconds. Okay, and you will see perform counter, everything is back to 0 because the workload is complete. How many latches occurred, friends? Let me do this. How many latches? Buffer? What is that? 15 lakhs? 47,670. Those many latches were required to perform this operation. Now, I am going to reset this back. Remember your count. And if you like the performance this time, you should applaud. When we did it with one user, it wasn't very appealing, right? So we are all back to 0. I reset the latch stacks. And now I am going to say in memory equals to 1. Right? 1000 rows and 100 users. Shall we begin? Guesses? How much time? Don't say 1 second, please. Don't say 1 second, 2 seconds. Be realistic. 1 minute? 2 minutes? 30 seconds. Okay, 30 seconds? 30 seconds seems to be a decent number. Okay, let's go. It's a little fair. Okay? Do you see anything in latches there? Nothing at all. There's no batch request per second showing anything. (1921). Wow, so we are done. 28 seconds. Awesome. 30 seconds was a very good hit. And what do you see on your count? Look at buffer. That's what you have to see. It is maybe some internal pages, but not our in-memory version. There will be some, because it does not give you table-wise, right? It gives you system-wise, right? That is your performance. And I just did it with insert, right? So with insert, your performance is not going to be leaps and bounds. This was still, what, 8 to 9 times, that took 4 minutes, 31 seconds. So it was like 9x performance that you got. But if you take a real workload, because not all users are going to insert, right? So they're going to be insert, update, select, etc. If you take real workload, you will see leaps and bounds of performance improvement in memory. I don't have much time with me, but I also want to show you the C# code, right? C code. Okay, so we have many tables, right, with which are now in memory optimized. So what I will do is, we have this one of the tables, right, sys order header in memory. That's my object ID, which is ending with 8371. Okay, and what I want to do is if we go to this path, data XTP 7, what did we end with? 8371, right? So if you see 8371, where is that? 8371.c. That's your table. That's not your store procedure. That's your table, which is compiled into a C code. So, which means, I mean, the table as well as store procedure is all C code, right? It's all machine code. And you can always open this, say with Notepad, yeah, and you can see all C code, and you can see those columns that are declared, right? Cat, uncat, varchar, all those things you can see. Right, friends? So here I keep a set of notes with me to just see if So I have done in memory, and I have shown you with the stress tool with 100 users and 1000 records, and you've seen the performance and you've seen the C code. So let's go back to the slide. So the table is memory optimized. Okay, so the table is durable. This is what we see, hash indexes, and we create secondary indexes. This is optional. Okay, you just need at least one index. Okay, any number of secondary indexes are optional. And let me go back to one of the previous slides that I wanted to talk about here is, okay, so
indexes work well on non-duplicate values or duplicate values. If it works well on duplicate values, more than duplicate values.
Which index?
Hash indexes.
Hash indexes work well with duplicate. So I won't say it about duplicate or non-duplicate. There could be duplicates or non-duplicates. Hash indexes will work very well if the data, the distribution is even. If you take 10 buckets and the number of rows are well divided in those 10 buckets, suppose you have 10 million rows and they're well divided 1 million each, that's the best performance it will be. But that's theoretically. Typically, if we see, it's not going to be very well distributed. For example, you have data about 3 years and you're bucketing with, say, a month, and you want to put, say, like 36 buckets. That's well distribution. That's the hash index. Now, one bucket has 1 million rows, the other bucket has only 1,000 rows. That's not going to work so well, right? Now, the point here is, so it's all good, okay? In-memory OLTP is good, it's the new version, and it gives you leaps and bounds of performance, awesome transactional throughput, right? Very low latency, and you've seen that in action. But what about your existing applications, your existing databases? The first challenge that you will have in your hand, and this is what I want the takeaway from here is, identify the tables that have the most latched contention. They are the best candidates to be migrated to in-memory. Now you might have number of master tables, right? Those master tables do not change so often, so you're not going to find a lot of latch contention there. But your heavily DML transaction tables, right, will have a lot of latch contention. They become your first candidate. Okay, identify them and look at this diagram. So you have your transactional log here, you have your data file groups, you have your typical buffer pool, you have 2-3 tables, you have their indexes, there is T-SQL query execution going on. This is your traditional SQL Server, right? Now, what you want to do is, you create a separate file group, okay? So now, a few more requirements are going to get clear with this diagram. That is, for in-memory OLTP tables, you need a separate file group. Just like file stream or file table, if you have known those concepts. Then you have these memory optimized tables and indexed structure, you have a separate file group. And you have identified that table T1 and T2 are good candidates to be moved into in-memory structure. Okay, it's a very simplified example. So what you do is you go and create new tables here, and then you have to move data. You can't convert an existing table to an in-memory OLTP table. You have to create a new table. You have to move data from your old tables to the new table, and then delete the old tables. Effectively, what you're doing is you're moving T1 and T2 to memory optimized. And now what's going to happen? This T-SQL query here, suppose there was a store prop which was actually working with T1, T2, and T3, right? It's going to continue to work with T1, T2, and T3. But now that is machine code. This is interpreted code. What's going to happen? There is something called as query interop. It's not visible on the slide, sorry about that. This says query interop. So there's going to be a query interop component here in-memory OLTP engine, which is actually going to convert the interpreted code to be used by the machine code. So for the client, for the stored procedure, they are still accessing T1, T2 and T3, but they will get much better performance overall because now T1 and T2 have moved into in-memory OLTP. Are you with me on this? However, it's just not about the tables. As I said, you can also have what we call as natively compiled stored procedure, right? From interpreted stored procedures to natively compiled C code. Now, in long term, you might want to convert existing stored procs, right? Or when you build new stored procs, you may want to convert them to native code, C code. One restriction you have is native code can only work with in-memory OLTP tables. Native code, C code, cannot work with traditional disk-based tables. However, traditional stored proc can work with both disk-based tables as well as in-memory tables. In this demo, I have not shown you the stored proc code. Okay, but just last slide in there. Yeah.
Suppose I tell you go A1 there. So can I go again that A1 to get?
So it's like again creating another table here and migrating the data, moving the data. Yeah, you can't do any alter table or something like that. Create new table, move the data. Then again go back in case you think that oh no, this is not what I wanted, you can always do that. Right? So that's the reverse engineering you will have to do. So I have explained, and here is that stored proc example quickly. Native compilation of the create. So these are all requirements. Execute as reverse scheme, but this is the most native compilation. The proc is natively compiled and as begin atomic with transaction. It actually uses snapshot isolation. Now this is mandatory syntax, and then your code which goes here. Now all T-SQL constructs are not supported, right? So you should refer to SQL Server documentation, 2014 documentation as to what constructs are not supported. But SQL Server team has taken all possible constructs that are commonly used in OLTP environment into account. Okay. Yes, only the snapshot isolation. Absolutely. On Twitter, I think that would be the easiest thing that you can do, and you will get notified when I post this slide and the code for you to practice out. A_Bansal is my Twitter handle, and this site is going to be up by next weekend. We are doing certain under construction, so if you want to connect with me on other social channels like LinkedIn, Facebook, etc., you can just go to amitbansal.com. And I cordially invite all of you to be member of SQLServerGeeks.com. We keep doing a lot of events, webcasts, sessions, and if you are members, you will automatically be notified. They are free. You can always come in. So a lot of speakers from the community and from Microsoft speak at our events. And if you like the session, did you enjoy the session? Yes. Yeah, concepts versus demo. Generally my sessions are very heavy demo oriented, but I think this time concepts were equally important to understand before we jump into simple, straightforward demos. So if you like my session, this is what you can tweet with in-memory OLTP with A_Bansal, and you can please put these hashtags. That's your thought of the day. Okay. Okay, so I am done with the session. Thank you very much for your time, for being a patient audience. You can always talk to me outside the room. I will be there. If you have more questions, I will love to answer them and catch me around. Thank you very much. Have a great night. Have a great conference. And connect with me. And in response to your feedback, do post some tweets. Thank you very much, friends.